Okay, section 6.1, goal 2 is on composition of functions. Instead of adding, subtracting, multiplying, and dividing, we're actually composing them by putting one function into the other. And so let's go over just a real basic concepts of functions to begin with. First of all, if you're given a function, you've got a function f of x equals 2x plus 1. Well, what is f of negative 7? Well, what we do is we take negative 7, actually what we do is we take the f of x function, take out the variable, and we plug in negative 7 into where the variable was. That's what we do with functions. That's how we evaluate functions. Of course, we always simplify if we can. And of course, this one is equal to negative 14 plus 1 is negative 13. So f of negative 7 is negative 13. If we put 2y in, we do the same thing. 2 times 2y plus 1. So f of 2y is equal to 4y plus 1. You just simplify it. Okay, the same thing with elephant. If we have f of elephant, you do exactly the same thing. 2 times elephant plus 1. And you simplify, and that's it. 2 elephants plus 1. Okay, so that's how you evaluate functions. Composition of functions is when you have a couple different functions. And this is written as either you've got f, an open circle of g of x, or f of g of x. Okay? If this is the case, then you are going to be putting whatever comes out of g into f for the variable. So if I have f of g of x, I take f of x, just like we did before, 2 times the parentheses plus 1, and I'm putting g of x into the f of x function. Now, if I had g of f of x instead, then I am taking the g function and I am putting f of x in for that. So I put 2x plus 1 in there. And again, we have to simplify. If I simplified the first one, I'd get 6x plus 8 plus 1. So that would be 6x plus 9. This one would be 6x plus 7. So they're not the same thing. Okay? Now, what happens if we take f of x? Well, what you do is you put f of x back into f of x. So you take the f of x function, but then you put in f of x into the function in the variable. So 2x plus 1 in there, so I get 4x plus 2 plus 1, so 4x plus 3. So you always put whatever's inside into the outside function. Okay, here's an example, 3a. This time they give us points or input-output values. And if we're doing the composition of f of g of x, basically what we do is we take x and we put that in to the g of x function. What comes out is g of x. We put whatever that is into the f of x function, and then whatever comes out of that is our range. So our domain is our x values that get put in. Whatever comes out of G goes into F. Whatever comes out of F is the range value. Okay, so using these points, we can try to do that. In this case, we start with the G of x. X, in this case, is 4. What comes out is 3, because that's the 3, or the output. That goes in to F. So that goes into the F function, which is here, and what comes out is -2. So an ordered pair of this one is 4, -2. So 4 goes in, goes to 3, 3 goes in, and comes out as -2. So our point for f of g of x starts with 4 and ends with -2. It kind of goes through 3 though. Another one starts with 2. It goes to 1, or excuse me, -1. So 2 goes to -1. So then it goes to f of -1, which comes out as -5. So 2 goes in, -5 comes out. We could keep doing this. 9 goes in, goes to 4, 4 goes in, goes to 7, so 9 goes in, 7 comes out. The last one, 3 goes in, goes to 10, 10 goes into F, comes out as 8. So those are my points of my composition. Now that was f of g of x. If we tried to do g of f of x, nothing may work. There might not be any ties to the, for example, let's just do this first one here. I'll erase this stuff up here so we can kind of follow it. Okay, so let's try this. Let's say we have this time g of f of x. So we start with x in the f of x function. So let's start with 3. It goes to f of x, which is -2. That then goes to the input of g, which is -2, which then goes to g of x. Is there any -2's in the beginning of g? And there is not. So it's not defined. We could not finish it because 3 went in, -2 came out, but there is no -2's down here to continue. So therefore, that one is not defined. We'd have to try all of them. If we put -1 in, -5 comes out, there are no -5's. 4 goes in, 7 comes out, there are no 7's. 10 goes in, 8 comes out, there are no 8's. So that one would be completely undefined. Okay, let's go ahead and try example 3b. 3b is just like the one we did over here to the left. So let's try that. Okay, so 3b is f of x is equal to x squared plus 2. G of x is equal to x minus 6. I want to find f of g of x. And then I'm going to find g of f of x. So if you want to pause the video and try it, go ahead and do that, and then start it back up again, and I'm going to finish it right now. So f of g of x, I start with f of x with parentheses plus squared plus 2, and then I put the g into it. And then I simplify. X squared minus 12x plus 36 plus 2 is x squared minus 12x plus 38. Now g of f of x, you start with g of x, so parentheses minus 6, and you put in the f of x function. So I end up with x squared minus 4. So as you can see, they are not the same. And that's how you do composition of functions.